Hello, we'll be back to the last video of the linked list. In this video, we're going to look at the last two methods that we can apply on a linked list. And one of the method is inserting at a particular index in a linked list with data. So this one will be inserting at a specified index with that data you are giving it. So we shall just call it and pass it the data we want to insert in the linked list plus the index at which you want to insert that data. Then the last method will be remove at, shall be removing at the where shall be removing at a particular index. So let us first implement removing at a particular index because for it's a little bit easier compared to inserting at a particular index. So we create a variable called remove at. So you pass index as a parameter. First of all, as usual, we're going to first check and see if we have a head. So if know this dot head, then it implies that our linked list is empty. We have no head, so we have no node in our linked list. We shall just return. Okay. We create another if condition and say if the index we are providing is equal to 0. Index equal to 0. Oh, sorry, here it's a typo. So if the index is equal to 0, okay, this means that we are accessing. We want to remove the head of our linked list. So if that's the case, this dot head will be equal to, so here index 0 is the head of our linked list. So if we want to remove the head of our linked list, we just update the head of the entire linked list to point to the next node of that head. So shall just say here this dot head will be equal to this dot head dot next. So you're just updating our head to be the next node in our linked list. Right. So we'll go to the last part of this logic of how we're going to be removing at a particular index. So we're going to create a variable. So what we're going to be doing here basically is that we're going to access, for example, in case we want to, so this is at index 0, this is at index 1, and this is at index 2. So for example, if we want to remove a node at index 1, which is this one, we have to have access to the previous node, which is this. So in case of the access to the previous node, that's why we should be updating its next to be the one after this one. Okay, so this one will be pointing to a point. Let me illustrate it here. So this one will be pointing to a point, to be pointing to this node here instead of pointing to this one. Okay, so let me write it in code here so that you can understand it better. All right, so let me write it here. So I'm going to create a variable const previous node. So previous node will be, remember we have a get at method that gives us the node at a particular index. So we're going to use that method also in solving this particular problem. So to access this dot get at, okay. So which index are we accessing? We're accessing the index before this index here, the index before this. So to get that, you can just subtract -1 from it. Okay, so there by this code here we're accessing the index before that node we want to remove. Okay, so if write an if statement here and say if there is no previous node, okay, or there is no previous node dot next. So this implies that if there is no node at this point, okay, then shall just return. So that shows that there is no node in our linked list. Else previous node dot next, previous node dot next will be equal to previous node dot next. So let me hope this line doesn't confuse you. I'm writing, remember at this point here we access the previous node. Let me say this one, access the previous node of this one. Okay, so we're having access to the previous, remember we want to move this one, but now we have got access to this node here. Okay, so here we are saying previous node dot next will be equal to previous node dot next dot next. So after accessing so previous node dot next will imply that we're accessing this. Okay, so the previous node, which is this one dot next, so we shall be pointing to this, hence removing this node from our linked list. Okay, so let me hope you understand that. So let me go to my last method, the very last method, which is inserting at a particular index. So insert at particular index, we pass it, we give it index, the index where we want to insert the data, then the data we want to insert along with that index. Alright, so as usual, we first check and see if there is no head. If there is no this dot head, meaning that our linked list is empty, then we create the head. This dot head will be equal to new node. So give it new node. Then we have to pass the index where we want to add the data. Okay. Oh no, this one doesn't require index. Doesn't require the index. Yeah. Okay, so we pass it index. Just pass the data you want to add. Since initially it was empty and we had no node at all, so if that's the case, we have no head, just add the node with this data. Okay, so just add the data, you don't mind about the index. Okay, so in case our index is 0, the index is equal to, in case the index is 0, what does that imply? In case I want to insert, remember this is our index, so in case I want to insert at this index, okay, I want to insert this node at this index here. What am I going to do? I'm going to update the head now. This dot head will be equal to new node. Okay, I'm passing the data. Okay, passing the data, and then the previous head. So this previous head will be now our next head for this new node. Okay, so then we're now going to do the last part whereby we're having an index that's greater than 0. So if that's the case, in case we're having index greater than 0, as I earlier told you, we access the index. So in case we want to insert at a particular index, first we have to access an index that's before that node. So if to do that, we want to say const previous nodes, okay, will be equal to this dot get at particular index. Remember that function we created earlier that returns for us the node at a particular index. So we want to access the index before that index whereby we want to add the new node. So we say index minus 1. Okay, but there might be scenarios whereby the user one is accessing the last node, the index which is at the end. For example, is wants to add a node at index what? At index 2. So this is index 2, alright? So to do that, to access that node, shall say O this dot get last. So this one will return for us the last node. Okay, so this will return for us the last node, right? So we will create another variable called the const node will be equal to new node. Okay, we pass in the data. So here the next node will be the previous node dot next, previous node dot next. So let me hope you understand up to this point here. First, we are accessing the previous node. For example, I want to insert here. I want to insert at this index here, which is index 1. Okay. So what I'm going to do, I'm going to access the previous node, okay, through this line of code. So after getting access to the previous node, which is this is the previous node to this, which is this one. I first create a node. I first create a node variable. This node variable is going to store as a node, which is which I'm going to add in our linked list. So this is the node I'm going to add. Okay, this one. I'm going to add it at index 1. So after creating it, you pass in the data, which is the information you want to add in that linked list. Then the reference to the next node. So the reference will be the reference to the next node of this one, which is what I'm going to add. Will be accessing the previous node dot next of this one, which is this one. So this one will be the next to this, right? So it will be something similar to this. Okay. So this will point here. Okay. And then this. Oh, sorry. Oh. So this will point here like that. Okay. Oh. So to be like that. So the next to this one will be the previous of this one, but next which is this one. So it will be the next of this node here. Okay. So after that, I just say previous node dot next. Oh, previous node dot next is equal to node. Okay. So the previous of this one will now be this new node we've created. Okay. So let me hope you've understood that point. Let me test out these two functions and I see whether we're on point. So let us remove at. So I want to remove at. Let me see. I want to remove at. Let me remove at. Let me see. Okay. Let me remove at. Remove. Let me remove at. Let me see. So let me remove at 1. So removing at 1, I should expect this value 10 to be removed from our linked list. Okay. Okay. Okay, I should expect that value to be removed from our linked list. So let me test out this dot remove. So here 10 we should be removed because 10 is at index 1. So let me test out this function and see. Oh, we're having an error somewhere. This would remove is undefined, not a function at line 160. Okay, might have made a typo somewhere. list dot remove add. Sorry for that error at 1. List dot remove at 1. So I should expect it to work. Okay, you see 10 has been removed from our list. Wonderful. 10 has been removed. So now we're having 11 and 12. Okay, so 10 has been, remember 10 has been in between 12 and 11, but now it has been removed because it's at index 1. Wonderful. So let me test out the last function, which is inserting at. So let me insert at that particular index. Let me insert at 1. List dot insert. Where should I insert? Where should I insert? Let me insert at 0. So 0 is having now 11. So let me insert at 0. Let me insert there 400. So here 11 should be shifted to index 1 so that index 0 can accommodate 200. Let me test out this. You see, at index 0 now we have 200. Wonderful. So 11 has been shifted to index 1. So thank you very much for watching this video. It has been a long video, I know, but you've learned a lot. We've covered very many methods that can apply on a linked list. So I'll continue to remind you to subscribe, share, and like this video. Yeah, thank you. In another video after this one, we shall be implementing like the applications, how a linked list can be applied in solving particular problems. So thank you for watching. Bye bye.